Welcome to the series How Does a Computer Work? A Bottom-up explanation. Which I'm going to be explaining to you how does a computer work. And first of all, of course, how is this series going to work? Got a little slide for you that. Here's a little graph of what topics we're be going through. First of all, this is going to be a bottom-up explanation. With that, I mean we're going to be starting in the physics layer and working our way up until we have a working processor in a way. So we're going to be starting with the transistor and going through binary logic. Binary logic is two things that need to be understood, of course, to understand how a computer is working. And yeah, when we are finished with the CPU, when that is done and explained, there will be probably a new series about operating systems. But yeah, there we will be going away from the hardware and into software, so this is not anymore the same general topic, so this will be a new series. Also, a little thanks and inspiration. I need to say, of course, this series was inspired by two lectures. First of all, Rechnerorganisation by Mixed Signal Circuit Design, held by Professor Dr. Ingenieur Friedel Gerfers, and Digitale Systeme by Quality and Usability Lab, Professor Dr. Ingenieur Sebastian Möller. Those are two lectures in the computational engineering direction. So if you are really interested in the things I'm explaining to you, you might want to consider studying computational engineering. Yeah. Also, a big thank you to Tobias Kaiser from Mixed Signal Circuit Design. He's supporting me in this series and also is proofreading things. Yeah, also, he's probably gonna watch this video. Hello! Yeah, now we continue with the first episode, which I'm going to be explaining what is a computer. To be, of course, understanding what's going on in the series, we need to first establish what is even a computer. Above me is a rather old computer, a picture of one, for example. Yeah, but we're gonna continue and first of all talk about many devices which are indeed computers. First of all, here that's a Raspberry Pi, a so-called mini computer. Pretty clear it's a computer. It has USB, it has a display, everything. It's just really small, but a computer nonetheless. Next of it, a gaming console, in this case a Game Boy Pocket. It's also a computer. It can play different kinds of games, which can be programmed by people, and change the game, do different things, of course, but yeah, it's limited in a way, but it's still a computer. Then this type of pocket calculator, this one is a Casio ClassPad 330, which is a programmable calculator, which is very important. If something is programmable, it is a computer. If it's not programmable, you can argue that it's not a computer indeed. So yeah, this pocket calculator, which is programmable, is definitely a computer. Some other pocket calculators might not be a computer. And next is a smartphone. Sometimes from people who are not that much into technology, I hear them saying that smartphones are not a computer. Smartphones are computers. They do exactly the same things your PC does, or can do exactly the same things, but they're just way slower with it because they don't have as much power and stuff, but they can do the same things, and it doesn't matter how fast a computer is, it just matters what it does. Yeah. Next of it, a bit behind me, a smartwatch, which is also a kind of computer. Smart watches also do basically things that a computer does, just even slower. And on that note, basically any device that has smart written in front of it is a computer in a sense. So, yes, your smart home is technically a lot of computers inside your home, which can possibly listen to all the things you say. Just wanted to say that. Yeah, there's of course many more devices that are computers or have computers inside of them. In our age, with that much technology around and how technology works nowadays, if you have a device that needs electricity and is not super simple, there is a pretty high chance that there's a computer inside, because it's just way easier for a company to get some kind of computer chip, program it, put it in the device, and call it a day, instead of making a whole new fabrication line for some specific type of logic they need. So, most coffee machines or new coffee machines or whatever device have a computer inside. Yeah. Now we're gonna go to the first computers. What the first computer was is arguable. Some people say it's one computer, some people say it's another. I'm just gonna talk about the Zuse Z1 as the first computer, though it might not be the first one. So yeah, but it is definitely one of the first. The Z1, as written, also is on your left side there, which is a rebuild from the actual Z1, which was destroyed in the war. Above me is also the Z3, which was actually also destroyed in the war and also rebuilt. So, yes, but actually rebuilt by the actual Zuse Z1. Yeah, very funny story. One person who worked with the Zuse Z1 said that he built it in his kitchen or something, I think, and realized later it does neither fit through the door nor the window, so they had to break a real big hole into the window wall and get the computer out of there to put it in the Technical Museum Berlin, where it stands today. And the Zuse Z3 is in the National Museum in Munich also. So, Technical Museum Berlin, if you want to look at the Zuse Z1, National Museum Munich, if you want to look at the Zuse Z3. Of course, the Technical Museum Berlin also has some similar computers to the one that's the Z3. But now we actually talk about what they even do. Zuse Z1 is a calculation device, and the very interesting thing about Zuse Z1 is it is not working with electrical signals. It is all on a physical way. There is like switches, like metal bars, lots of them that are moving about and moving parts inside of it, and doing the calculation by just moving the parts in a way that it's actually doing things. It's also quite interesting to see that live, because there is all like a really big amount of those like long metal things. Yeah, it's quite interesting. It tends a bit to jam up sometimes, though, because of course it's mechanical, but still quite nice to see. The Zuse Z3 is working on relay switches, which is like a predecessor, like the one what that was before. I hope predecessor is the right word for that, of the transistor. So it does work in with electrical signals, but also quite interesting. Yeah. Now we go into the parts of a computer. Up to the left, in orange, we have the one of the most important parts, the processing unit. The processing unit is basically the brains of the computer. It does calculations. It like executes instructions. So the computer like does can like run through programs. Of course, then in the middle we have the bus. in green. And the bus is basically a connection between all parts. That's why I did like the little graphy things there. Like the lines between that. The bus is the thing that connects everything together. Above me, the two things are data and instruction storage. They're both in the same color because in an actual computer, most of the time they are stored on the same device. Basically, they both go into your hard drive in your .c or whatever drive you're using, and basically data storage is if you like any kind of data, like a picture, text, whatever, a book, that would be data storage. If you store that on your computer, like a picture of a cute cat would be data storage. Instruction storage is all your programs, or rather the programming code in a way that gets executed. That would be instruction storage, just things that tell the processing unit what to do. And in the left, in red, that's the last part, is I/O. That's just user input output, any kind of human interface devices. Your screen would be an output, like the thing you're looking at. Hello, you're looking at a screen right now. That is a output. And a keyboard, for example, would be an input. Your mouse is also an input. That's just a few examples. There's of course way more than that. Now a little picture of my computer, a modern PC, and how that actually looks. I just go into a laser pointer so I can show you. You have of course all the same parts, but some parts are there several times, some parts, I mean most parts are there several times. For example, here you have the CPU, that's the central processing unit, with a little bit of storage on it, the bus connected to the RAM, which is the fast memory of your computer, which your CPU is most likely going to be reading off of because it's just way faster than your main storage, which is your drives. I don't know, your drive C, D, E, whatever letter you gave it in Windows, or just whatever directory you gave it in Linux, of course, or Mac OS, though Mac OS is technically just Linux and fancy. Yeah. Then, of course, you have, or every computer has a GPU, graphics processing unit, which one is, this one is here, like in this big blocky thing here, which is handling all the graphics calculation. So you can look at things on your screen, you can play games, that's all what the GPU does. It's a very specialized into just doing graphics basically. Yeah. That's a GPU, and in this case I have also a network card installed. This is a Wi-Fi card, so I can use Wi-Fi on my PC, which gets handled by this. And all the red things are input output. I don't know, I can't see it properly, but I don't know, here's for example USB. I don't know if that's exactly the USB port. Here's audio. This one would be a front panel USB port, so you can like put in USB sticks in the front and don't always have to crawl to the back of your computer to access USB ports and stuff like that. Yeah, and of course, yeah, main drives. And this is also very general. You could probably find all kinds of processing chips everywhere on here, or much more bus than that if you open your computer. Like if you have a not laptop, laptops are a bit difficult to open, and I don't recommend it if you don't know what you're doing. But with some computers you can just easily, like PCs, standalone PCs, desktop PCs, you can take your side panel off and like look into it and just explore a bit around. Just if you don't know what you're doing, don't touch anything. It's my recommendation. If you know what you're doing, you know what you're doing. I don't need to explain this to you. Yeah. That's the parts of a computer. Next off, what does a computer even do? We have two things. We have instructions, we have data. And question mark, question mark, question mark, that's our CPU. I did it in question mark, question mark, question mark because I'm gonna be explaining in this whole series how the processor or the CPU even does the things it does. And then you have an output. For example, you have edit file, we're writing something in a file, the data is the file at the address, which is just display beyond low, user desktop homework placeholder.txt something, and I don't know, we write lorem ipsum inside of the file. Nice. That would be something we would be doing. And of course we would expect to lorem ipsum to be displayed in the file afterwards. That's what our CPU is handling. Of course, both the instructions and the data can change. For example, we can go to display picture at web address. Here's the actual web address of the picture. This cute frog here. And yeah, we expect if we want to display a picture at this web address that there will be a picture displayed from the web address. And of course, our computer needs to calculate something there. Yeah, it is just very, very general, and we won't go up until such a high level that you can actually do this. The commands we will be putting into a computer or into the CPU we are building will be way simpler than display picture. Just to be warning you, but from going to the things we're doing to display picture, we need to go through the whole OS. Yeah, so that's basically what a computer does, which I explained to you. We have now a few sources, that's the links. The links will also be in the description if you want to look at the things. Most of it is from Wikipedia. So, yeah. There's also all the attribution, all the licenses are in the video description. So, look at it if you want. And, yeah, this is now the end of the video. You can click away now, yeah? Don't worry, I won't be saying anything very important anymore. I know it's sometimes very scary to press the away button, something, but you can do it. I believe in you. Bye-bye. I think everybody should be gone now. If not, why are you still here? Like, why? The video's over.